Okay, so we give another example on how to apply the first shift theorem. The problem is to use the first shift theorem to find a function whose Fourier transform is 1/3 plus I into k minus 2, given that the Fourier transform of u of t e raised to minus mt is 1/m plus ik for positive values of m. Remember, u is the unit step function. U is the unit step function given in this form. So then now, to solve this, from the definition given, we have the Fourier transform of u of t. Now, when you let m to be 3, so we'll have e raised to minus 3t should give us 1 over, so where there's m, we are putting 3 plus ik. So this is what we'll call the f of k. Now, the given transform 1/3 plus I into k minus 2 would be simply be given by f of k minus 2. If you know this f of k, then obviously this must be k minus f of k minus 2. So therefore, from the first shift theorem, with a given by 2, we have that the Fourier transform of e raised to 2 I t multiplied by u of t e raised to negative 3t will be given by 3 over 3, will be given by 1/3 plus 1/3 plus I into k minus 2. So therefore, the function required, hence the required function whose Fourier transform is 1/3 plus I into k minus 2 is u of t multiplied by e raised to negative 3 minus 2i times t. So this is the solution to that particular problem. Another example on the application also of the first shift theorem. So example 2, find the Fourier series or the Fourier transform of a function f of t given by e raised to negative 3t when t is non-negative, e raised to 3t when t is negative, and then from this deduce the function post Fourier transform is g of k given by 6 divided by 10 plus 2k plus k squared. So that's the problem. So we are going to get the answer from definition of a Fourier transform, and then once we have the Fourier transform of the given function f of t, we use first theorem to answer the last part. So solution. We know that the Fourier transform of this function, any function f, is given by the integral from minus infinity to positive infinity of f of t e raised to negative IKT dt. This by definition. Now, the interesting thing about the limits we are given, so we have minus infinity, positive infinity, and we have been given a 0 here. So this interval from minus infinity to positive infinity has been split into two subintervals, where from minus infinity to 0, we have function e raised to minus 3t, and 0 to infinity. Okay, so from minus infinity to 0, we have e raised power 3t, and this other one will have e raised power minus 3t. So we are going to split this integral into two subintegrals. So we'll have f of k will be the integral from minus infinity to 0 of e raised power 3t e raised power negative IKT dt plus 0 to infinity e raised power minus 3t e raised power negative IKT dt. Also the definition of the function f of t. Now we can rewrite this as the integral from minus infinity to 0 e raised power 3 minus ik times t dt, and then plus 0 to infinity e raised power negative 3 plus ik t dt. So the first one, so we'll have f of k will be limit as r approaches infinity, approaches negative infinity, r to 0, e raised power 3 minus 3 minus ik t dt plus limit as r approaches infinity, integral from 0 to r of e raised power negative 3 plus ik t dt. Now, using u substitution, this first integral will be 1 over 3 minus ik limit as r approaches minus infinity of e raised power 3 minus ik t from r to t equals to 0. This other one will be now plus but minus 1 over 3 plus ik limit r approaches infinity of, so e raised power negative 3 plus IKT t from 0 to t equals to r. Now, lower limit, when you put negative infinity, we'll have 1 over 3 minus ik. So we'll have limit as r approaches negative infinity of now e raised power 3 minus ik r. Put 0 just gets 0. Minus 1 over 3 plus ik into limit as r approaches infinity e raised power negative 3 plus ik r minus 1. So when you put r for negative infinity, now we'll have 1 over e raised power 3 minus ik, and then infinity. So that limit will be 0. So remember, this is 1, not 0. So this will just be negative 1 over 3 Okay, so the interpretation of the first, the upper limit is what is 0. So for this other one here, we have t for 0 will give us 1. And then, so first we have 1 minus limit as r approaches negative infinity, e raised power 3 minus ik r. This is what we have. So we'll have this limit will be 0. So 1 over 3 minus ik into 1 minus 0 minus 1 over 3 plus ik into, so this limit will be 0 minus 1. So which ends up to be f of k. Remember, this is f of k, gives 1 over 3 minus ik. Now minus minus plus 1 over 3 plus ik. So putting over 1 LCM, so 3 minus ik, 3 plus ik. So 3 plus ik minus 3 plus 3 minus ik. So which will be f of k. Numerator will give us 6, because complex parts cancels out. And then these are different of 2 squares, so 3 squared is 9. And then minus, now plus k squared. Because we'll have negative, and then I squared k squared. I squared is minus 1, so minus minus k squared is positive k squared. So therefore, f of k is 6 over 9 plus omega squared. But now, g of k is given by 6 over 10 plus 2k plus k squared. Now you see, we complete the squares. So k squared plus 2k plus 10. So b over 2 squared. So b is 2. 2 divided by 2 is 1. So we'll have k plus 2k and then plus 1 squared. And so for me to have 10, so I need to add 9 so that I don't lose the original meaning of the expression. And then from here to here is k plus 1 squared. 9 is the same as 3 squared. So you can say g of k can be written as 6 over k plus 1 squared, and then plus 3 squared, or simply plus 9. So if f of k is given by 6 over, actually this is the same as 3 squared, k squared plus 3 squared, then 6 over k plus 1 squared plus 3 squared, obviously should give us f of k plus 1. We see that the structure is the same, only this part is what you're changing from k to k plus 1. So this implies that the g of k is the same as f of k plus 1, and therefore using the first shift property, therefore the first shift property f of k plus 1 will be the Fourier transform of the function minus it multiplied by f of t, i.e. the required function now will be taking e raised to power negative t times f of t, which was given initially. So we'll have g of t equals to e raised to power negative it times f of t, which was e raised to power negative 3t, e raised to power 3t. This was t non-negative, and this was t negative. So, which is the same as, you simply multiply the e raised to power negative it to each of the two parts, and then you say g of t is given by the function e raised to power negative 3 minus I times t, and this other will be e raised to power 3 minus I times t, and then limits do not change, t greater than or equals to 0, this one t less than 0. So this is a final solution. Thank you.